Determine if each sequence converges or diverges. If it converges, determine what it converges to. To answer this question, we treat a sub n as a function of n and determine the limit as n approaches infinity of a sub n. If the limit exists, then the sequence converges and it converges to the value of the limit. If the limit doesn't exist, the sequence diverges. There's several ways we can go about determining this limit. Notice the degree of the numerator and the degree of the denominator are both 3, which means the limit is going to be equal to the ratio of the leading coefficients, which is going to be 2/8 or 1/4. Or if we want to show some work, we can divide each term by the highest power of n in the denominator. I'm going to go ahead and show that. Notice the highest power of n in the denominator is n cubed. I will now divide every term in the numerator and denominator by n cubed. This will give us the limit as n approaches infinity of 2n cubed divided by n cubed. And then for the denominator, we'd have 8n cubed divided by n cubed plus 4 divided by n cubed. And now we simplify. N cubed divided by itself simplifies to 1 here as well as here. We now have the limit as n approaches infinity of just 2 divided by the sum of 8 and 4 divided by n cubed. Notice now, only 4 divided by n cubed is affected by n, and 4 divided by n cubed approaches 0 as n approaches infinity, giving us a limit equal to 2/8, which once again simplifies to 1/4. So the sequence converges, and it converges to 1/4. Let's take a look at this graphically. To show the graph of the sequence, we will graph points on the coordinate plane in the form of n, comma, a sub n, and now let's plot the first 50 points. We can think of the y value as the terms in the sequence, and notice the y values do approach and converge to the value of 0.25, which is 1/4. Let's look at our second example. We begin by considering the limit as n approaches infinity of a sub n, which is now n to the 7th power, divided by the difference of 2n to the 4th and 9. Comparing the degrees, notice the degree of the numerator is greater than the degree of the denominator. The degree of the numerator is 7. The degree of the denominator is 4. This indicates the numerator is growing faster than the denominator, and therefore the limit will approach infinity. But again, to show work, we can also divide each term by the highest power of n in the denominator, which is n to the 4th. So we'll go ahead and show that work. We would have n to the 7th divided by n to the 4th, all divided by the difference of 2n to the 4th divided by n to the 4th, and 9 divided by n to the 4th. And now we simplify. N to the 7th divided by n to the 4th is equal to n cubed. Recall when dividing the bases are the same, we subtract the exponents. And now in the denominator, n to the 4th divided by n to the 4th simplifies to 1, leaving us with just 2. We have 2 minus 9 divided by n to the 4th. As n approaches infinity, 9 divided by n to the 4th approaches 0. N cubed approaches positive infinity. Positive infinity divided by 2 is still positive infinity. The limit approaches positive infinity, which is not a real number and therefore does not exist, which indicates the sequence diverges. More specifically, the terms in the sequence get larger and larger in the positive direction. Let's also look at this graphically. Once again, we'll plot points on the coordinate plane in the form of n, comma, a sub n, and we'll plot the first 50 points. And notice the y values quickly increase without bound, which is why the limit approached infinity and the sequence diverges. I hope you found this helpful.